Okay, so we have done quite a bit with systems so far in Unit 3, and it is now time to really focus on those real world situations. So we've done a little bit along the way when we did our different methods using algebra, but today and the next couple of days, we're just going to really focus on those word problems because honestly, that is how you're going to see systems moving forward, is just the real world situations and when you're going to have to use them. Today, since we're just really focusing on word problems, we're just going to make sure that you can define your variables when you're given a word problem and set up the system. We have spent a whole week now solving those systems, so we'll just take a pause on the actual solving because hopefully at this point you're feeling pretty good about that, and let's just practice setting them up today. That's our goal. So let's start off with just a basic equation that you can translate the words into an equation here. So your warm-up today is translate this into an equation. 5 more than 3 times a number is 14. Pause your video and see if you can do it. All right, so when I look at a sentence like this and I'm trying to make an equation, I usually go through and try to pick out the word is, right? Our word is where we're going to see our equal sign. If it's right in front of something that says less than or more than, is less than, is more than, that's going to be our indication that we're going to have an inequality symbol, right? Less than or greater than or something like that. If it says is at most or is at least or something like that. So the word is really important to kind of get our bearings on what our equation is going to look like. So the word is going to be our equal sign. And then on the right-hand side of the word is, I see 14. So really we're thinking whatever this is going to equal 14. So it says 5 more than 3 times a number is 14. So when it says 5 more than, right, I'm going to be adding 5 plus something because I want to have 5 more than whatever that is. I should scooch it a little bit closer to my equation here. So 5 plus, and then it says 3 times a number. And wherever we have the words a number, that's going to be our variable, right? X equals a number. So we should define what our variable is going to stand for. So in this equation, I want to have 3 times that number, so it will be 3x. So our final equation there would be 5 plus 3x equals 14. Hopefully you got that one right. So now we're going to take that idea and we're going to put it into an idea of systems, right? We're going to take those words, translate them into 2 equations and not just 1. We're going to be defining our variables, and remember, to have a system, I have to have 2 variables and not just 1. So we're going to make sure that we're always defining 2 different variables here. So here's our first problem. The difference between 2 numbers is 9. 3 times the smaller plus 5 times the larger is 61. What are the numbers? All right, so when I start out by defining my variables, right? And I think, what are the things that I don't know? What are the things that I'm trying to find? So here we're talking about 2 numbers. It says, what are the numbers, right? And we talked about the difference between 2 numbers. So I'm talking about 2 numbers. In the second sentence, it talks about a smaller and a larger. So that's how I'm going to define my 2 variables. Let's say that x equals the larger number. And we'll say that y equals the smaller number. Now, sometimes, it doesn't, you could call it the x the smaller number if you want and y the larger. You can define your variables however you want to, but just make sure that you're indicating which one is the bigger and which one is the smaller, because it might pop into play here and when we talk about our sentences and writing our equations. So my first sentence says the difference between these 2 numbers is 9. There's that key word 9, right? So when I'm talking about the difference, I am subtracting. So I'm going to subtract these 2 numbers. Now the answer equals 9, right? The difference between these 2 numbers is 9. Now 9 is a positive number. So if I get a positive number for my answer, I have to take the bigger number minus the smaller number, and not the other way around. If I took a smaller number minus a bigger number, I'd get a negative answer. And so that's why we need to indicate which one's the larger number and which one is the smaller number. So in this case, it has to be x minus y to get a positive answer. Okay, so my first equation for my first sentence there, x minus y equals 9. The difference between these two numbers is 9. All right, now my second sentence says 3 times the smaller number, smaller was y, right? I like to kind of write it down, plus 5 times the larger number, that was x, is 61. There's my important word is, right? So in this equation, it's going to equal 61. So I'll have 3 times the smaller number, which was y, plus 5 times the larger number, which was x, is 61. So 3y plus 5x equals 61 for this system. So we've defined our variables and we wrote our 2 equations. Now this one was set up nice for us, right? One sentence was one equation. The second sentence, the second equation. A lot of times that's going to be the case. So really be looking out for that as a possibility. Not always, but sometimes it is. A lot of times it is. And so really kind of think about one sentence, one equation, second sentence, second equation. And most of the time that'll work out. Now we don't have to solve this one. If we did though, what do you think the first thing would be that you would do? Well, it kind of depends. If you're going to use substitution, maybe you want to add y on the top equation to the other side so that you get x by itself. If you're going to use elimination, you would have to make sure that your equations are in standard form. So the second equation, you would have to rearrange a little bit and then figure out what you need to multiply by. We aren't actually going to practice that. Like I said, you've been doing it for a week, but just keep in mind, what are the things that you would do if you were going to actually solve them? All right, let's take a look at the next one. Here it says, the perimeter of a rectangle is 108 centimeters. If the length of the rectangle is 5 times the width, what are the dimensions of the rectangle? All right, now in a problem like this, I like to draw a picture. When you draw a picture, that's the same thing as defining your variables, right? And when I have something like this and it says length and width, I like to use variables that kind of make sense in the problem. So I'm going to call L the length, right? L equals the length of the rectangle, and there are 2 of them in that picture, one on the top and one on the bottom. And I'm going to call W the width of that rectangle. So I've defined my variables just by drawing the picture. The L stands for length, W stands for width. And now when we have a system, we can actually use those 2 variables like a lot of you wanted to do back in Unit 1, but you didn't know how to do it yet. Okay, so my first sentence says that the perimeter of this rectangle is 108 centimeters. So I should be able to write that equation, right? Based off of that information, the perimeter. Perimeter is where you add up all of the sides. Now, I see that I would have L plus W plus L plus W, so you could write it that way, or we could say I would have 2L plus 2W equals 108, right? The perimeter equals 108. So don't forget that you have 2 lengths and 2 widths, and that's why I put them both in my picture so I don't forget. So perimeter 2L plus 2W equals 108. All right, now the next sentence says, the length of the rectangle, length was L, right? The length of the rectangle is, the length is 5 times the width, that was W. So the length of the rectangle, so L is, that's where I'm going to write my equal sign, 5 times the width. And there's my second equation. It's a very small equation, not a lot going on. L equals 5W, but it's still an equation, and I got that from my problem, my second sentence there. So I have my system set up. 2L plus 2W equals 108, and L equals 5W. Now, if you think about how you would actually solve this one, hopefully substitution is jumping out at you, right? I could just take that 5W, plug it in for L, and I'd be ready to go, okay? But we do need to set up the system with 2 variables and 2 equations to start out with, so make sure that you're always doing that on your homework tonight. Okay, let's keep moving. Number 3, 2 angles are supplementary. The sum of the measures of the larger angle and twice the smaller angle is 265 degrees. Find the measure of the larger angle. Now, back in Unit 1, we learned how to do this with only one variable. We did it all with just x, and we had our variables defined always the same way. But I want to show you in Unit 3 how you can do it with two variables. So please, for these lessons, I would like you to use two variables when you set up these systems so that you can learn a new method. After Unit 3, you can pick whichever method you like better, but since we're in this unit on systems, we would like you to try and use a system to learn a new way to do it. I know we did the same ones back in Unit 1, okay? So let's try to do this with two variables. So when we're talking about this, we're talking about two angles, right? Two angles are supplementary. And then in my second sentence, it says that we're talking about a larger angle and a smaller angle. So very similar to the first problem, I'm going to define my variables by saying x equals the larger angle and y equals the smaller angle. Okay? So these two angles are supplementary. This is our first sentence. They are supplementary. So if we remember back to Unit 1, supplementary angles means that they add up to 180, right? So I'm going to add the larger angle plus the smaller angle, and they're going to add up, excuse me, to 180 degrees. There's our first equation, x plus y equals 180. So that when they told us that they are supplementary, that creates an equation for us when we're using a system. Now the second sentence is where I'm going to get my second equation. So it says the sum, so we're adding, the sum of the measures of the larger angle, that was x, and twice the smaller angle, that was y, is 265. So it's going to equal 265. So the measure of the larger angle, so x, and twice the smaller angle, so 2y, equals 265. There's my second equation. So my system x plus y equals 180 and x plus 2y equals 265. All right, now if you were going to solve this, I would probably do elimination on this one. I mean, you could just multiply one of those equations by a -1 and cancel the x's, or multiply the top equation by -2 and cancel the y's. I mean, I guess you could move either the x or the y on the top equation and use substitution. You have so many options here to solve that one, but we're not going to focus on that one today. All right, number 5 here. Jason has 18 coins in his pocket, consisting of some dimes and some quarters. The total value of the coins is $3.45. How many of each type of coin does he have? All right, so as I define my variables here, I see that I'm talking about dimes and quarters. Now, we all know what a dime is worth and a quarter is worth, right? So when I define my variables, I'm going to be very specific that we are talking about the number of dimes and the number of quarters. Now, when I do coin problems, I like to use variables that make sense. You can always use x and y on every problem, but for me, I like to use, say, d for the number of dimes, and I'm going to use q for the number of quarters. Again, you can use whatever you would like for variables, but sometimes I like to use letters that make sense in the problem. It helps my brain wrap around what I've got here. So in his pocket, he's got a total of 18 coins. There are 18 coins in his pocket. Some are dimes and some are quarters. Now, I don't know how many of each, but I know that the number of dimes plus the number of quarters has to equal 18, right? The number of the two different types of coins have to add up to 18. So my equation to start off with is going to say D, which is the number of dimes, plus Q, which is the number of quarters, has to equal 18. If you have a total of 18 coins, the number of dimes plus the number of quarters has to equal 18. All right, now the second sentence says that the total value, excuse me, the total value of these coins is $3.45. All right, so now I need to have how much a dime is worth and how much a quarter is worth come into play, right? So a dime is worth 10 cents. So the value of all the dimes would be 10 cents times the number of dimes, right? So 0.10 times D. Plus the value of a quarter is 0.25, right? 25 cents times the number of quarters will be the total value of all the quarters. So I need the total value of all the dimes plus the total value of all the quarters, and that has to equal $3.45. So my top equation dealt with the number of coins. The bottom equation dealt with the value of the coins. So one of them didn't have the 10 cents and the 25 cents. The other one did. So really, when you're dealing with money, that's your real big clue for how to set them up, okay? One equation will deal with the total number, and the other equation will deal with the total value. Whenever you deal with money, really think about that as setting up your system. All right, now those money ones seem to be tricky for a lot of students. So we're going to do one more of those as our last problem here in notes, just setting it up. So this time I have a collection of dimes and nickels that totals $3.55. There are 10 more dimes than nickels. How many of each coin are there? All right, so again, I'm going to use variables that make sense to me. So D for the number of dimes, be specific. Don't just say dimes, say number of dimes. And I'm going to say N as the number of nickels. All right. So this time it says a collection of dimes and nickels totals $3.55. So in this one, we're talking about the total value, right? If we're talking about money here for the total, we're talking about the total value. So I need to make sure that I put the value in my first equation. So each dime is worth 10 cents. So I'll have 10 cents times the number of dimes plus 0.05, right? 5 cents times the number of nickels. And that will give me the total value of $3.55. So my first equation actually dealt with the total value this time. Now the second one is dealing with the number. There are 10 more dimes than nickels. The number of dimes is 10 more than the number of nickels, right? Now do you see how I kind of reworded that? Sometimes when it's worded like this, it's a little bit confusing. So I kind of reworded in my head. So the number of dimes is 10 more than the number of nickels. The other way, because sometimes it's hard to think about which one do I have to add the 10 to, right? So sometimes I have students, and it'll be a little bit difficult because you're not actually seeing me right now, but I have students kind of hold up their hands like a scale. And I say, which stack has more, right? There are 10 more dimes than nickels. So my left hand is my dime stack and my right hand is my nickel stack. If there are 10 more dimes than nickels, my left hand with the dimes would be higher up. It'll have more, right? More dimes than nickels. And so if I want to get them to be equal, I have to add 10 to the nickels for them to be the same, right? So either way, if you can't rewrite it in your head and change those words around till it's a sentence that you can write an equation for, then start to think about, okay, which one has more to start with? So what do I have to add to get them to be at the same level? All right, so here, dimes, the number of dimes, so that was D, is 10 more than the number of nickels. And that was N. So our equation would say D equals, oops, I wanted to put D in right. D equals 10 plus N. The number of dimes is 10 more than the number of nickels. There are 10 more dimes than nickels. I'm adding 10 to the number of nickels to be the number of dimes. Those seem to be really tricky. That's why I walked you through it a whole bunch of different ways. Hopefully that helps you out. So again, today we're just going to focus on defining your variables, making sure that you can write that system. 2 variables, 2 equations every time, but you don't have to solve them. If you want to solve them, it's great practice, but you are not required to solve them today. Only set them up and define your variables. And then when you're talking about, especially with money, think about if you're talking about the total value or the total number, and you should have one equation for each. Will really help you make sure that you get both equations. All right, good luck.